there are two kind of graphs plotted. One is distance time or displacement time graph. And the second one is called velocity time or speed time graph. There is also acceleration time graph, but from that acceleration time graph a new quantity which is not required mostly. That's why in your syllabus there are two graphs can be drawn. One is distance times or displacement time or velocity time or speed time graph. Now for these two curves, time is always in the x-axis. That means for the plotting of graph we have to know the two axes. One is along x-axis, another is along y-axis. There are two axes. This vertical axis is called y-axis. This horizontal axis is called x-axis. Now, from that point to that, if we draw the y-axis above direction, then it is the positive y-axis. If it is drawn in the negative side, then it is negative y-axis. From this side, if we draw this side as positive x-axis, then from this side it is called negative x-axis. So there are four axis system. One is for above this, which is positive y-axis, below this negative y-axis, this side is positive x-axis, this side is negative x-axis. Now from this side and from that side there are two variables. One is distance and time. Now always for these two graphs, always time is plot against x-axis. So in this axis time is plot along the x-axis, as times cannot be reversed back. Time cannot be reversed back. That means there is no significance of the negative x-axis. So in case of time duration, we always plot time axis along the x-axis and it is in the positive x direction. Now along the y-axis, these variables can be plotted. If it is a distance time, then y-axis is represented by distance. And along y-axis, if displacement time is graph is plotted, then along y-axis it is positive displacement. Now distance cannot be negative as it is a scalar quantity. If the body displaces or if the body travels some path, then distance is also there. So distance cannot be 0 or distance cannot be negative. So whenever we plot distance time graph, distance should be in the positive y-axis. But if displacement time is graph is plotted, displacement is a direction dependent quantity. That means displacement can either be positive or be negative. For displacement time graph, we have required these two quantities, but for the distance time graph, we have required only the positive y-axis and positive x-axis. But in case of displacement time graph, then we have to draw positive as well as negative axis because it is a direction dependent. So if we plot velocity time graph, then time is always in the x-axis. Velocity is plotted against y-axis, positive y-axis, and as well as negative x-axis. Speed, as it is doesn't depend on the direction, that's why speed is only plot against y-axis. So speed is in the form of positive y-axis. So there are four different graphs which can be specified for the particles motion or the body's motion by distance time, displacement time, velocity time and speed time graph. Now if the body is at rest and we have to draw is distance time graph, what is the nature of the graph? Suppose this is a distance time graph and body is at rest. That means body doesn't change its position. Initially the body should be 5 meter distance from the origin. So it is in 5 meter. Now as time goes on, the body doesn't displace. So the body remains at 5 meter throughout the journey. Time goes on, but the body will remain at 5 meter distance from the starting to the last point. That means the body is at rest. So this is the curve for the body is at rest. The body is at rest. The graph should be like that. It is the parallel to the time axis if we plot distance time graph. Now, if the body moving with a uniform velocity, then what is the nature of the curve? This is the distance, this is the time. Now, if the body moving with a uniform velocity, then the curve should be like that. It is a straight line passing through origin. What is significance of this kind of graph? Now, the body displaces from this origin in a straight line mode. That means the distance gradually increases. The distance gradually increases. So, distance from the distance time graph, if we calculate the speed of the curve which is in uniform speed, then the nature of the curve should be like that. So, the body's motion, it is uniform velocity. Body moving with uniform velocity. Why? Because the distance time ratio of this curve should be remain same. How we calculate the distance time ratio? If we plot a rectangular, if we plot a right angular triangle from this graph, it's a right angle triangle and this angle is 90 degree. So, from this point, it is the hypotenuse, it is the base and it is the height, because we have to draw this is the angle. So, this is the base and this is the height. Now, height by base gives you the slope of the curve. Now, the slope of the curve represent the distance by time. So, slope of distance time gives you the information about velocity. Now, in this kind of graph, the slope of the graph at each point of that curve should be remain fixed. As it is remain fixed, that means the body is in uniform velocity. The body doesn't change in the velocity from. That means it is in constant velocity or uniform velocity. So, we can write it as a constant velocity or uniform velocity. Now, if the body doesn't move in uniform velocity, then what happens? If the body doesn't move with uniform velocity, that means it is in non-uniform velocity, then the curve should be like that. It is not a straight line, it is a curved one. That means at every point the slope should be varied. At that point, the slope value is different. At that point, the slope value is also different. So, at every point, the value of the slope is different. That means the body is in non-uniform motion or non-uniform velocity. So, this is the curve in which the body doesn't move with a constant velocity. So, from the distance time graph, we have to know the information about velocity or the speed. If we draw distance time, then this informs us about speed. If it is a displacement time, then it is actually helpful for calculating the velocity. Now, velocity is calculated by the help of taking slope of the curve. Now, in this graph, there is a shortcoming. What is the shortcoming? We can't say about acceleration or retardation. For this purpose, we have to draw the velocity time graph. So, for the velocity time graph, there are two directions possible because velocity is the time dependent factor. So, as velocity is a time dependent factor and it is a direction dependent factor, that's why positive as well as negative direction is considered. Now, along this positive y axis, velocity is there and time is there. Now, if the body's motion is in uniform velocity, that means in a constant velocity, and the velocity is like that 6 meter per second. Initially the body moves with a 6 meter per second. Now after sometime the body is also moving with a 6 meter per second. That means the body will remain at 6 meter of time whatever the time is. So throughout the journey the body will remain at 6 meter per second. So this is the motion of a body which is moving with constant velocity. So this is the graph with constant velocity movement. Now, if the body moving with a random velocity, then what is the nature of the curve? If the body moving with a variable velocity, that means non-uniform motion, then the body's motion should be like that. Why? Because the velocity's value is changes with respect to time. Now, if we draw similarly the slope of the velocity time graph, that means it is a right angle triangle, this is then theta, this is a height and this is a base. Height is velocity, base is time. So velocity by time, that would give the acceleration. So as velocity time graph, the slope of velocity time graph gives you the value of acceleration or retardation. When retardation is taken into account, if the body is moving in a like that way, body is moving in a direction which is gradually decreasing. That means as time goes on, initially the body is here with a certain kind of velocity and this velocity is maximum. Suppose it is 10 meter per second. Now after time interval, this is, suppose it is a 5 meter. Now if that portion is happen again, then this value is 3 meter. So gradually the change in velocity with respect to time is decreasing. So this kind of graph represent the body's motion which is in a retardation mode. So there are two kind of plotting of graph. One is for acceleration and one is for retardation. So whenever the body moving, velocity time graph, if it is in a straight line passing through origin, then the body will moving with a uniform acceleration or constant acceleration. So it is the body's motion with constant acceleration because the value of the slope is similar at every point. So velocity time graph gives an idea about acceleration or the retardation. Now, by drawing this kind of graphs, we can actually get the information about distance from the velocity time graph. How? If we draw velocity time graph is like that. So it is a body's motion which is in a constant acceleration. Now if we draw a perpendicular at that particular point, then this is a triangle whose height is this is a height, and whose base is this. Now base is given the information of time, height is inform us about velocity. Now the area of that triangle, so area of a triangle half into base into height. Now half into base is time, height is velocity. Now velocity into time, that part velocity into time gives you the amount of displacement. So in case of velocity time graph, if we draw the area under the curve, that particular curve which actually locate a particular area which is like that, and if we calculate this area, we can actually inform about the distance. So for velocity time graph, we have to calculate its area, and that area would give you the information about the distance.